Hello everyone, welcome to Homework Help. If you find the videos useful, please subscribe to the channel. So in this video, we'll solve this optimization problem using derivatives. So as per the problem, a piece of wire 100 centimeter long needs to be bent to form a rectangle and determine the dimensions of the rectangle with the maximum area. So that means we need to find how can we make a rectangle from a 100 centimeter long wire so that the rectangle has the maximum possible area. So the first step here is to draw a diagram for this problem. And now this problem is based on the shape of a rectangle. So we should draw a rectangle. So let's assume the length of this rectangle is L and the width is W. Now the 100 centimeter wire has been used to create this rectangle. That means the perimeter of this rectangle is equal to 100. So that is our first equation. So we do L plus W plus L plus W. So for perimeter, we have to add the lengths of all four sides of this rectangle equals 100 centimeter. Now we can combine the like terms on the left side. So we get 2L plus 2W equals 100. And now we can reduce this equation by dividing each term by 2. So we get L plus W equals 50. So this is the first equation we get using these two variables L and W. Now we have to determine the dimensions that maximize area. So the next step is to write the equation for area of this rectangle. And we know that the area of a rectangle is equal to length times width. Now this area equation has two variables, L and W. So the next step is to isolate L or W from the perimeter equation and do the substitution in this area equation. So we can isolate L from the perimeter equation. So for that we'll have to move W to the right side of the equation. So we get L equals 50 minus W. Now we can do the substitution for L in the area equation. So we get area equals 50 minus W times W. Now we can distribute the W into the parentheses. So we get area equals 50W minus W squared. So this is the expression for area of this rectangle. Now we have to find the dimensions for maximum area. So for that we'll have to find the derivative of this area expression, because we need to find the values of W at which the slope of the tangent is horizontal. Because for maximum area we need to find the W values at which the uh, tangent is horizontal, and that those will also be the peaks in the graph of this area function. So we can find the area, the derivative of this area function using the power rule. So the derivative of 50W the first term in the area expression will just be 50. So prime of A will be equal to 50 minus, and then the prime of W square as per the power rule will be 2W. So this is the derivative of the area function, and now we'll set it equal to 0 to solve for W, because we want to find the W values at the peak of the function, and at the peak the slope of the tangent, which is also the derivative of the expression, will be equal to 0. So now we have to isolate W in this equation. So for that we should add 2W to both sides of the equation. So the two W's on the right side we cancel out. So we get 2W equals 50, and now we can isolate W by dividing both sides by 2. So the 2's on the left side cancel each other out, and we get W equals 25. And the unit will be centimeters. Now we have to determine the dimensions with the maximum area. Now this is the W value we got where the tangent is horizontal. Now we also have to consider the interval for W for this problem. Now as per the perimeter equation, L plus W is equal to 50. So we know that the width of the rectangle has to be greater than 0. So the interval for W can be written as, so W has to be greater than 0, and it should be less than 50, because if the length of the rectangle becomes 0, as per the perimeter equation, the W will be equal to 50, but length cannot be equal to 0, because if the length becomes equal to 0, then the rectangle will become a straight line. So that's why W should be any value between 0 and 50. So this is a very important concept we need to understand and memorize. Now we have to find the area of this rectangle for the three W values. So the two W values from the extremes of the interval, and this W value that we got from the derivative. So we have to find area at 0 centimeter for the W value, and for that we'll use this expression for area. So A at 0 will be equal to 50 times 0 minus 0 square, which will just be equal to 0. Now we can find the value of area at a W value of 25. So we get 50 times 25 minus 25 square. So A at 25 equals, so first we have to do 50 times 25 and minus 25 square, and I got 625, and the unit will be centimeter square, because that's the given unit of length in the problem. And next we'll have to find the area at W equals 50, because that's the upper limit for the width. So that will be, so 50 times 50 minus 50 square. So A at 50 equals, so this will be equal to 0. So that means the width that gives us the maximum area is 25, because this is the maximum value for area we got from these three W values. So for our answer, we'll write W equals 25 centimeter, Now we'll also have to calculate the value of L because dimensions includes both length and W for a rectangle. And for length, we got the expression L equals 50 minus W. Now we'll sub in W as 25, so 50 minus 25, so L equals 25 centimeter. So these are the dimensions of the rectangle that will give us the maximum area. So this should be the final answer for this problem. So these are the steps you have to keep in mind to solve an optimization problem like this one. So a very important step is to draw a diagram for this problem because this problem is based on a shape. And then we write out the perimeter equation based on the given length of the wire. And then we write the area equation because we have to find the dimensions for maximum area. So I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.